Okay. So the main goal of this webinar is to show you a little bit how we model CPS inside INTO-CPS project. INTO-CPS project is a research project focused on FMI co-simulation of CPS. So we use Modelio, which is the tool you should see now on your screen, to model the FME involved inside the co-simulation, but also their connection. So first step, once you create a project INTO-CPS project, the first step is usually creating what we called inside INTO-CPS an architectural structure diagram, which allow you to represent your system in terms of specialized block. We got system block, CC component, E component, PO component block. So we build a profile on top of CSML profile in order to represent our system and the concept involved in your system. So you usually start by creating a system. A system can be composed of one or many C component. C component is a kind of block which allow you to regroup some concept. And as for CSML, you can specify the composition by creating composition link between your top block, your system, and the sub block here, two C component. And then you can refine your system with any level of confinement. At some point, you could have what we describe here as an E component. An E component is in INTO-CPS will be a FMU. So this kind of component will be a FMU, a dedicated FMU for co-simulation. Once again, you can have composition link between this component and this its owner. For each of them, you can specify the kind of model, discrete one, continuous one. You can specify also if it's cyber element, physical, what we call subsystem, environment, and visualization. All these kind of blocks have been defined in order to regroup FMU for different co-simulation. For example, if you want to focus only on the cyber part of the simulation, this co-simulation configuration will be generated by taking into account all the cyber component part, and the simulation with only cyber part will be made. Of course, we can have another component type physical, which allow you to have co-simulation for the physical part of your system. And if you want both part, cyber and physical part, you select that you need co-simulation from all components tagged as cyber or physical part. Then for each E component, you can add some ports which represent the input, output of each of them. You can specify type, Boolean, integer, interval, well, string. Do we have any question maybe in chat? How do you specify multiple instances of components such for machine build it up the system? The multiplicity as in SysML in UML is specified here. You got a little number here where you can specify min, max instance of this. So it's coming from UML and SysML. So you can specify that your C component is composed of 4 instances of E component, or this E component. Mainly how you specify instances and multiple instances. But you have to be careful in the fact that all instances of this E component will be related to one unique FMU, which means that all 4 instances here will have the same behavior, represented by one file, one C code, in fact, one DLL. So you cannot distinguish any of them. Or the 4 of them will have the same behavior. Or what if we need to design communication between 2 machines? Between 2 machines among these 4, or between 2 different components? Among the 4, you cannot distinguish communication from 2 of them inside the 4 of them. You should have to separate met 2 group. You can regroup 2 of these E component at once, and you can, with the port, you can specify communication of these 2 ports. So you will have 2 instances of this component. If each of them will have 1 port, so it means you will have 2 ports, each 1 port per instance, and these 2 ports will be could be connected to 1 port of 2 instances, also, or 2 port with 2 multiplicity. But if you want to distinguish any behavior, any communication, anything between this instance, you have to change the multiplicity inside. In order to specify a communication between blocks or instance of blocks, you have to create for INTO-CPS what we call connection diagram. Inside SysML is called internal block diagram, and for UML it's more composite structure part. The principle of all these diagrams is mainly the same. You have block instance here with port. You get another port instance with another port. You can type your instance by using one of the previous block made here. You can type the other one in order to specify which behavior you will have. And then you can, once you create the port, which must be the same as the port created here, same type, same definition. You are able to create connection between them. Maybe it's better to create this way. In fact, this wizard create for you all port present on the type. They create this good port in the instance, and then you are able to connection is not good. I have to change the direction. You have to our input ports. If I made an update, I'll get an input port now, and I'm able to connect output to input ports. So that's mainly how we describe connection between all between instance of predefined type. You're welcome. Then from this kind of modeling, you are able to generate what we call inside INTO-CPS configuration, co-simulation configuration, which is used by co-simulation orchestration engine, another part of the project, to simulate the connection or the timing of all this connection and behavior of all FMUs. But that's part of another tool involved inside INTO-CPS. If you are interested in a small demo or maybe just some video, I can maybe send you some link after this meeting to this and maybe to other technology made inside INTO-CPS project. So I heard that you were interested about how we distinguish cyber and physical entity inside CPS design. For us, the difference between them is really few, because that's only a tag here, physical or cyber, or we can also use another concept called environment or visualization in order to separate what is cyber, what is physical, because at the end, all of them will be exported, or the behavior, all of them will be inside an FMU, will be a DLL of C code. And the matter is, we do not really matter if it's physical or cyber. What matters is more if it's discrete modeling, it's continuous modeling, which could be a difference between physical and cyber. Do you have any question on this? Guess again, I will stop